Hello everyone, welcome to our channel Renewable Energy Study Group, where we are actually discussing the topics regarding the renewable energy like the solar energy, wind energy, biomass energy, geothermal energy, and all other kinds of energy. So in the today's session, we're going to be talk about the design case study of solar home systems for DC loads. So in this video, we're going to be focused upon how we can design the solar home systems at our residential cases wherever we are utilizing the DC load in a given system. So one by one, we'll take one problem statement and we try to solve all this case and we can able to design the overall system. So let's say for a study purpose, we're going to take a numerical or the problem statement like that. Design a solar DC home system for the given list DC load shown in the following table, which is used by the small home system. Design a DC solar home system in such a way that it should satisfy the need of consumer at least for 5 hours of end duration. So for this problem statement, we consider that the given consumer is having this much amount of an DC equipment he is utilizing, and we have to design this kind of a system as the problem statement and the requisite requirement. So let's say whenever we are designing any solar home system, that to be a DC kind of a home system, we must know how many kind of the equipment the consumer is utilizing. Let's say for DC fan, DC LED light, DC tube light, these are the equipments this particular consumer is having. So we must know what is the wattage rating of the individual equipment. Like a DC fan is having 27 watt, DC LED light is having the 10 watt, DC tube light is having the 18 watt. That we have to write in this particular column. Then we must know how much quantity of that particular equipment will be available. Like the DC fan in the 3 quantities, DC LED light in the 5 quantities, and DC tube light in the 3 quantities. So once we have taken this basically, then we can calculate the total watt consumption for this kind of an equipment. As we know that the DC fan is consuming the 27 wattage, multiplied by this number of quantity, we get on an average the 81 wattage will be the load of the DC fan on a system. Similarly, for the DC LED light also will take 10, that is a power rating, multiplied by the quantity, that is a 5, and we get the 50 wattage will be the load rating. Similarly, for the DC tube light, we take 18 multiplied by 3, we'll get the 54 will be the overall load. Once we have taken this particular parameter, we must know the duty cycle of the corresponding equipment also. It means that how many number of hours the consumer is utilizing this kind of an DC equipment whenever we are designing the solar system for this kind of the cases. So let's say the duty cycle will be of the 6. It means for the 6 hours of the duration, individual equipment will going to be utilized in this particular case. Now we're going to be calculate how much amount of the kilowatt capacity will be required to design for the solar system. So in that particular perspective, we have to calculate the overall consumption in the watt hour case, because the consumption actually we are measuring in terms of the watt hour, that is how many number of wattage has been required by the individual equipment, multiply by the number of hours that equipment will going to be work out. So simply we're going to be multiply all these particular parameter, like the total number of the load, as we know for the DC fan is 81 wattage, multiply by how many number of hours we are utilizing individual equipment. From this we get 486. Similarly, for the DC LED light also, that is of 50 will be the overall wattage, multiplied by the duty cycle of the 6, that is of 300. DC tube light also 54 wattage, multiplied by the 6 hours it will going to be run, that is a 324. This will be the watt hour consumption. So in this column we'll get this particular value in terms of an watt hour also. Now, once we have taken all this particular equipment watt hour consumption, we have to add this particular column actually. It is because the overall consumption we require to identify, and from that purpose we can able to decide how much quantity of the solar DC home system that we can install on the given system. So we'll just going to be add this particular parameter and we'll get the overall value as 1110 watt hour. So this is the overall consumption of the consumer on the individual day or the single day we can say. So we divide this value by 1000. So we get this value in terms of an kilowatt hour, because as we know that the 1 watt hour or the kilowatt hour consumption when we take, then 1 kilowatt hour is equivalent to 1000 watt hour. And that is why we have to divide it by the 1000. And from this, we get the daily unit consumption, or we can say the daily electricity consumption in terms of an kilowatt hour, that is of 1.11 kilowatt hour. Then whenever we want to design this particular kind of the solar system, then stipulated parameter we have to be identify, or the formulas that we have to be consider over here. Once we have calculated the daily unit consumption in terms of an kilowatt hour, that is of 1.11 kilowatt hour, this particular value we have to divide it by the average sunshine hour which is been available on the given site. So basically, let's say the average sunshine hour which has been available on the given site are typically different based upon the location to location and country to country. So let's say the average sunshine hour in this particular case study will going to be take it over here as an 4. So this particular value of 1.11 kilowatt hour, we have to be divided by 4 and we get the answer as an 0.278 kilowatt. So this particular value of kilowatt rating, it depends upon how much amount of an average sunshine hours has been available on the given site, because that is a decisive factor for calculation and selection of the solar plant capacity in terms of an kilowatt. Similarly, once we have calculated, then we can calculate the total number of solar panel required in a given system. Then how we can able to decide that? Once we know that the total system that we are actually designing as per the calculation, which is 0.278 kilowatt, this much amount of the capacity. So which is actually close to the 300 wattage capacity that also we can identify over here. So if we take the 100 watt one panel, then we can just take this combination in series and parallel also. So let's say we'll take any panel of the random manufacturer who is able to manufacture this particular panel. So let's say the Vari solar panel that will going to be considered. So whenever we are actually doing the further calculation for connection of the solar panel, we must know the data sheet of the solar panel. So in a data sheet, we have to focus some important parameter like the peak watt rating of the panel, VMPP, that is a power point voltage of that particular panel, that is a maximum power point voltage, maximum power point current that you can say, open circuit voltage, short circuit current, maximum series fuse rating, efficiency of module, and the rated voltage of the corresponding module. This is an efficient parameter that we have to be considered before the calculation and connection of the solar panel for the given system. Now, once we have selected this particular panel, the formula saying that the total number of panels that we have to use in a system are total load consumption in watt in the daily basis. As we know that the total load consumption in watt was 3 watt, that is our capacity that we have calculated, which is 0.278 kilowatt. So overall plant size that we can say it is of 300 wattage on an average, divided by the panel rating that is of 100, and from this we get this particular answer as an 3. Once we have calculated the total number of solar panel, then we have to be consider how we exactly connect this panel in series and parallel combination. There are multiple factors are actually depending whenever we are doing the string combination in the solar system. As we can say that the connection of the solar panel, if we consider the 3 panels are connected in the parallel combination. So whenever we are connecting the panels in the parallel combination, their current value will going to be increased in the subsequent amount actually. Because whenever we are doing any parallel circuit, their current will going to increase, but the voltage will remain same. Similarly, on the reverse way, when we are connecting the panel in the series combination, their voltage will going to increase and the current will going to remain the same over here. So if I want to increase the current in a system, then we have to use the panel in the parallel combination. And whenever we want to use the increase the voltage in the series combination, then in that case, we can use the series combination over here. So in this case, we keep the rated voltage remain same, that is of 12 volt on an average on that basis over here. So as we know that the individual voltage of solar panel is 17.47 volt. Current of the each panel is 5.73 ampere as per the data sheet. So when we are connecting the panel in parallel combination, their voltage will remain same, but the current will going to increase like this. So 5.73 multiplied by 3. So we are getting 17.19 ampere. This will be the final current that we are getting from this particular solar panel over here. Once we have connected the panel in series and parallel combination, then we have to select the charge controller for the solar system. For selection of any charge controller for the DC system, we must know what is the current is flowing from the particular array, and that to be the output current that is collected from the overall solar array. That is of 17.19 ampere. So we just multiply this value by a safety factor of 1.25 and we get the answer of 21.48 ampere. So this is a on an average charge controller rating we have to select, or whichever feasible availability in the market will be there. So that kind of the controller we can able to select. So as per the market standard, we can select the 12 volt 20 ampere of the solar charge controller, or you can take 40 ampere of the charge controller also if future expansion plan is been there for the consumer in that particular case. So we can say that as per the market condition, the 20 ampere solar charge controller will be more than sufficient for designing for this kind of the DC home system. Once we have designed this particular thing, then we have to calculate the sizing of the battery also, because this is the upgrade kind of the system when we talk about the DC load system actually. So in that case, we must calculate how much amount of the battery backup will be required as per the problem statement. So size of the battery bank actually depends upon what is the regular consumption of the consumer is there. So as per the final calculation in the initial case, we have calculated that 1110 watt hour. This will be the consumption of the consumer. So we just consider this consumption and we can use this formula like this. Total capacity of the battery bank is total power consumption in the watt hour for the consumer, multiply by the number of days of autonomy. It means how many days we have to be required this backup for 1 day, 2 day, 3 day, based upon the remote location and availability of the sunshine hours, and also the availability of the seasonal wise also this parameter will going to be changed. But in this case, for a calculation, we'll take number of days of autonomy as 1 over here. This will be divided by the system voltage. System voltage is nothing but the how much amount of the rated voltage that we are getting from the panel. Rather, we can also say the rated voltage of the solar charge controller, or rather we also can say the battery bank voltage that we are giving to the charge controller. This will remain same over here. So if we take the 12 volt of the charge controller, then we must give the solar battery current voltage basically in the near about the 12 volt. Similarly, for the voltage that we are getting from the panel, and that to be the rated voltage, we can say it is closely the 12 volt, because the voltage from the panel will going to be vary depending upon the radiation, but the solar charge controller and the battery bank voltage will be remain same, like the 12 volt, 24 volt, 48 volt, 96 volt, depending upon that. This value should be multiplied by the percentage depth of discharge. It means that every battery has been defined as the percentage depth of discharge. It means that how much amount of the battery power that we can utilize. So let's say any battery is having the 90% of depth of discharge. It means what, up to the 90%, when the battery is getting empty, that much amount of power we can take out from the battery. And whenever the 10% power is remaining, we have to recharge this battery from the given system. So for the solar combination, actually, we prefer to go for the 90% of depth of discharge, or we can say it is a deep cycle battery, because we require to take out the more amount of the power, because for a solar region, night time, we don't have the power from the solar case. Some of the cases you can use the 80% depth of discharge also, or 90% also will be feasible for that. So from this calculation, we get the answer in terms of an ampere hour. So let's say the 1110 watt hour multiplied by the 1 day of autonomy divided by the 12 volt multiplied by the 0.9, that is a percentage DOD. And from this, we get the total capacity of battery bank for the given system for the requisite requirement of the consumer as 102.77 ampere hour. So whichever the close market size of the battery rating will be there as per our calculation, that we can able to select over here. So in this case, we can select the market size battery bank as a 12 volt battery that is of 100 ampere hour, which is close to our calculated value. This is the solar battery we can able to select. Thereafter, we can decide whether how many number of battery we have to connect in series, how many number of battery we have to connect in the parallel combination. So for that purpose, you can use this formula. Total number of batteries are connected in series combination is nothing but the overall battery bank voltage divided by the voltage of individual solar battery that you are connecting. So in this case, the battery bank voltage will be the 12 volt and each battery voltage will be of 12. So from this, we are getting the one answer, that is of one number of battery that we are connecting in the series combination. Similarly, for parallel combination, it exactly depends upon how much ampere hour rating that we are selecting or calculating for the given system. So formula says that the total capacity of battery bank as per our calculation divided by individual capacity of battery bank. So in this case, we have taken the 100 ampere hour of an battery. If you are taking 50 ampere hour of battery, then the two number of batteries we require to be connect in the parallel combination. Because in the parallel combination, the ampere hour of battery is increasing, but the voltage will remain same. And whenever we are connecting the batteries in series combination, their voltage will increase and the ampere hour will remain same. So this basic fundamental concept that we have to be understood whenever we are designing or selecting this kind of an batteries. So as per the calculation, we get the number of battery that were to be connected in the parallel combination, which is a 1. So the total battery that we have to be connect in the system is nothing but total number of battery we have calculated in parallel combination multiplied by number of batteries in the series combination. And from this we get the answer as an 1. 1 multiplied by 1 is 1. And we can go for the 12 volt 100 ampere hour of an battery for this kind of the DC home systems. Lastly, we're going to be see the connection diagram of this. So we have this kind of an 3 number of panels that we have actually connected in the parallel combination. And this connection we have to give to the controller. Controller work is to control the amount of voltage and current that we are getting from the panel. Try to utilize the maximum amount of the current and voltage to be extracted from the solar panel. Give this particular current and voltage in the proper format to the battery. When the battery is discharged, supply the current and voltage. When the battery is overcharging, basically cut off this particular power. So this is the intelligence functionality, this NPPT charge controller that we are getting in the market. And another supply that we can give to the DC connected load, because this kind of the system that we are designing, it is a DC kind of the home system. So in this way, we can able to design this kind of the solar DC home system for our home appliances and our home system like this. So in this particular YouTube channel, we are providing you the diverse kind of a knowledge in the renewable sector. So we have a dedicated website you can visit whenever you have a time and you just go for it, like www.renewableenergystudygroup.in. So on this particular website, you can visit, you can see the various amount of the courses we are offering, like a solar, wind, biomass, then we have a waste management, e-waste management, and all other parameter which are been related to the renewable kind of the energy. We are offering the various kinds of the offer for the various courses on our website also. So just go for visit to this particular website and take the maximum amount of the knowledge that you can get it from the renewable energy. Do share, like, and subscribe our YouTube channel. Thank you.